Hi everyone. I have some very good news to you. I don't want to sell you anything today, except some knowledge, but I hope that's okay. So today I'm going to talk about Windows domain security. And before we deep dive into the technical details, I want to ask you a question. How many of you guys are domain admins as a daily job? Okay, and how many of you gained domain admin privileges, even if you don't have any domain admin privileges as your daily job? Okay, good. So my name is Zoltan Balazs, and I do a lot of offensive research. For example, I'm the developer of the Zombie Browser toolkit. I developed the hardware firewall bypass toolkit, which is a kernel driver. I developed the malware analysis sandbox tester tool, and I also played with some crappy IoT devices in the past. And it's pretty funny because one of my exploit codes ended up in botnet, so it was running on 60,000 IP devices. So let's talk about Windows domains, shall we? In the very old days, when there was no domain, if you think about a university, there are some users and there are some resources they want to access. And if these systems are not connected well together, then you have to create accounts on all of the resources separately for all the users. So if we are talking about a university with thousands of users and thousands of resources, it's pretty a nightmare to manage all this stuff. Right? So there was this idea that we should create a centralized database for all the accounts. So whenever someone wants to access a resource, the resource can consult with this domain controller, and it will give the users access if they have. Okay, I'm pretty sure all of you are familiar with this, but it's very important to see that whenever someone gains domain admin privileges, it means that this someone can reset anyone's password, access anyone's email, log on to anyone's computer, install any software on these computers, access all the files, create new CS certificates. So pretty much everything can be done in that domain. So this is how it really feels like if you gain domain admin privileges. I never tried this, but I'm sure in a real-life scenario it will be a little bit different than in the DuckTales movies. Okay, so whenever there are attackers, they want to achieve their tasks, and it's in a Windows domain environment, it's a typical four-step scenario. First, they have no privileges, usually on the network, which is zero privilege, but they gain user privileges. From the user privileges, they usually escalate their privileges to local admin. From local admin, they escalate their privileges to domain admin. And this means if they have this domain admin privilege, they can use it to achieve their tasks. Let's talk about the first one, when the attacker has no privilege on the network, but wants to have some user privileges. The very easy way to do that is to, for example, infect the user with a malware. There are many different ways how you can do this. For example, you can use Office macro to infect the user. You can exploit the browser or a browser plugin like Flash, or use a vulnerability in Office itself. Actually, it looks like that nowadays the browser type exploits are dying, so we can see less and less of those exploits, but office exploits are on the rise at the moment. And of course, if you have physical access to a machine, then you can do a lot of things. I will talk about this later. One very easy way to gain user-level privileges is if you use some kind of phishing. I used to say that phishing is lame, and I told this because for me it's not an exciting thing to phish users, but turns out that even though I think it's lame, it works. It worked in the past, it works today, and I'm sure that it will work 10 years from now. Okay, so let's talk about how attackers can gain privileges if they have access to the local network itself. In the very old days, they could hack some servers to gain privileges on that server itself. For example, we used to hack Tomcat or GBoss application servers a lot. And the way it works is that you scan the network, you find one of these application servers. Sometimes they are not protected with passwords at all, or they are protected with some default passwords. You can log into the admin page, you can deploy your own application, and your application is actually a malicious code which runs with the application server privileges on the server itself. I myself, I have no idea how Tomcat or GBoss works. I only know that in the past it was a very good way to gain privileges on a remote server. Also in the very old days, MS SQL Server was a pretty good target to hack a server, but nowadays this is not the best target anymore. You can use this responder tool, which I will talk about later. Or last but not least, you can use some good old exploits, which exploit a service in Microsoft Windows itself. For example, if you remember from 2008, the config worm exploited this MS8067 exploit, or just last year, the Eternal Blue exploit was used to hack basically every Ampere system in the world via these ransomwares. So let's talk about Responder itself. Responder, it's basically a tool which first has to be in a man-in-the-middle position on the network. And whenever it has this man-in-the-middle position, it checks the network traffic. And whenever it sees that someone tries to access to an SMB server, MS SQL, HTTPS, LDAP, FTP, whatever server, it responds instantly to this request that, hey, I am this server, please authenticate to me. And the good thing about this approach is that basically this responder can collect all the hashes which are used to authenticate to these services. You can do many things with these hashes you collect. First, you can try to crack it if the password is weak. Or you can use the SMB relay tool to basically relay the authentication itself. So how this works is that the victim is trying to authenticate to a server, but as you are in the man-in-the-middle position, it will authenticate to you, and you will use this authentication to a server of your choice. And if the original user has access to this server service you want to relate to, then basically you get the access to this server itself. Thing is that if SMB signing is implemented in the network, it will break all these kind of attacks. So if you are working on the blue team, you should really enable SMB signing itself. If the attacker has physical access to the machines and the machine itself is not encrypted with BitLocker or something similar, there are many steps how they can gain user or admin level privileges on this machine itself. One of the best tricks is the good old SetHC trick. You boot into, for example, a Linux machine or something else, and you replace the SetHC exe with your own binary. Usually we use CMD for this trick. And next time when you boot the screen and you hit the shift key 3 times, it will start sethc.exe, which is a helper tool basically. But because you replaced it with the command prompt, instead of sethc, you will see a command prompt without logging into the machine itself. You can also try some rainbow table hacking. How many of you guys heard about rainbow tables? Okay, pretty much everyone. But turns out that nowadays hacking with rainbow tables is not the best way anymore, because there are these badass machines you can buy for $5,000 US on the market. And with a machine like this, you can crack 200 gigahash per second for NTLM hashes. And I know this is just a number, so it doesn't mean anything to you. But this means that if your users in your Windows environment are using really random passwords and they have uppercase, lowercase, and digits, and it is 10 character long, with this machine, someone can crack the password hashes and crack the passwords itself on an average of 22 days. And these are for totally random 10 character passwords. So I think it's pretty scary. Okay, let's talk about now that the attacker somehow gained user privileges, how they can gain local admin privileges. First of all, there is this trick we call privilege escalation, which means that you have already access to a system, but with lower level privileges, and you want to escalate to higher levels. Many people told me that, yeah, on Windows XP, for example, it is very trivial to do that, but turns out that if XP was set up properly and all the patches were installed, this is not a trivial task at all. For example, if you remember the Stuxnet malware, which was used in Iron, then it also implemented some zero-day attacks against Windows XP just to escalate the privileges itself. It is a very easy way to privilege escalation if you have some vulnerable services on the machine itself. As an attacker, what you can do is that you stop the service if you have the right to do that. You can replace the binary behind the service itself, and you can start the service, and now your binary will run with the service privileges, which is optimally system level privileges or something like that. It is very important to note that this is a vulnerability in the service itself because the permissions are too permissive. So this is a bug which has to be fixed, but we can see this issue in enterprise environments a lot. One of my favorites is this endless UAC prompts. For example, there is malware in the wide which checks whether the user has the admin level privileges, but UAC is blocking it. So it will constantly ask the user to approve the admin level privileges for the malware itself. And if you check the name of the executable which is running, it is a totally legitimate Adobe Flash Player installer. The malware basically brings its own Flash Player with it, just trick the user to give it the admin level privileges. And last but not least, you can try to check for credentials in clear text or in some password safe. Sometimes it can be fruitful as well. Okay, now when the attacker has local admin privileges on a machine, what can he do? Sometimes attackers need to pivot between systems, which means that if he is local admin on one system, he wants to be local admin on another system. And in order to pivot between the systems, the attacker needs password or a hash or a Kerberos ticket. And thing is that extracting hashes from the Windows memory it was pretty easy before the latest Windows 3 Enterprise versions. And thing is that you can use these hashes to authenticate to other systems itself, which means you don't have to crack it, which means it can be as complex as the user wants. You don't have to crack it, you can just use the hash or the Kerberos ticket to authenticate to other services. And this technique is called pass the hash. Pass the hash is not new. How many of you guys are familiar with the concept of pass the hash? Okay, like half. So from an architectural point of view, pass the hash is not a bug in itself, but this is a way how a network can work. Because let's assume that you log into your Windows machine and you constantly access resources on the network. You access printer, you access network file shares, you access the web proxy, you access the Exchange server. And it would be a nightmare or basically impossible to use a Windows machine if you have to type your password every time you access these resources, right? And the only way how this can really work if Windows stores the password hash itself in the memory and it can access it anytime it wants to authenticate to a network service. And because this is basically an issue in the architecture itself, it's very, very hard to fix it. In the latest Windows 10 versions, they are basically trying to move these hashes into operating system layer, which is inaccessible even with system level privileges on the system. So now when the attacker extracts the hashes from the system, and if he sets this hash in his Windows system in the memory, attacker can use this hash to authenticate to all the services which is accessible to the user itself. And there is this very funny thing called vdigest. I think it's not a thing anymore in latest Windows versions, but it's basically a clear text password in the memory, which means that you don't have to use all the pass the hash tricks to authenticate, because you can extract the clear text Windows memory, clear text Windows password from the memory itself. Okay, so now we have the hash of a local admin user. What can we do with it? We can use it to authenticate to another machine on the network. On Windows 7 and later, if you as an attacker has the local admin hashes and you want to authenticate to another machine on the domain, luckily it will be blocked because Windows thinks that this is not a legit thing that one local admin is trying to authenticate to another machine with local admin privileges if this is a domain computer, right? Why not using the domain privileges? So there is this default policy called local account token filter policy, which prevents this kind of attack. But thing is that due to operational reasons, a lot of companies turn this off because they have usually good reasons why they have to turn this off. So in this case, the good old pass the hash attack still works. We can, now as an attacker, we can log in to another machine. And usually, as an attacker, what you want to attack is a machine where a domain administrator is already logged in, right? Because that would be your next step to gain domain admin privileges. But if you are an attacker on a network which you have no idea how it works, how do you find the machine where the domain admins are logged in? There are some old school methods how you can do this and some pretty new stuff. The old school method is that you query the Active Directory and you look for domain admins. You can use some of these netgroup commands or the newer PowerShell PowerView commands to query basically the domain where you can find these users. But there is this new awesome stuff called Bloodhound, which is basically using graph theory to find the shortest path from the machine you already own to another machine where a domain admin is already logged in. For Bloodhound to work, it has to know basically 3 different things from the network. It has to know who is logged in where. It has to know which user can administer which resources and which user is in which groups. And the funny thing is that on Windows, all of these informations can be queried from an Active Directory without any special admin level privileges. Just a plain user on the Windows domain can ask all of these questions. This is a very simple use case how this Bloodhound tool works. In this case, the attacker starts on the top right corner, and what you can see in this picture that the attacker has access to this watahog@corpacme.com computer, and this computer this is the admin user, and this admin user has admin level privileges on the file server itself. And on the file server, there is an admin user logged in, which is inside the domain admin groups. This is just a lab network, so that's why it's so you can see so few nodes on this. But this is a real-life scenario, and this is still not a very huge network itself. And what you can see on this diagram, that if you are the attacker on the left, and you want to if domain admin privileges, which are on the right, these are all the different paths you can go through to achieve domain admin privileges. And I think that this is a very, very cool way to audit Windows domain environments, because now you can tell the IT operations, not just that this is the way I have achieved domain admin in your network, but you can tell them these are all the 1,000 ways how an attacker can gain domain admin privileges. And I really think that this is very, very cool stuff, and it's not just cool for red teaming or penetration testers, but if you are into blue teaming and you have to defend your network, you really should use Bloodhound to find out this kind of stuff. Okay, so we talked about pass the hash, which is about the Windows NTLM protocol, but some people told in the past, okay, let's just forget NTLM and move to Kerberos and everything will be fine, right? Unfortunately, at the end of the day, Kerberos has to work the same as NTLM works, because it has to keep something in the memory, which is used to authenticate to all the resources. So now the attacker doesn't have to steal an NTLM hash, but he has to steal a Kerberos ticket, but with this Kerberos ticket, he can access everything on the network. So it's the same way, same thing at the end of the day. What can we, as an attacker, do if we already access machine where a domain admin is logged in and we already have admin level privileges on this machine? Well, this means it is basically game over, because now the attacker can extract all the hashes or Kerberos tickets from this machine, and now the attacker can authenticate to a domain controller, and because now the attacker has domain admin privileges on the domain controller, it can do basically anything. It can create, for example, a new domain controller on his machine, sync all the data to his machine. This data includes all the users or password hashes, and after that he can remove his domain controller from the network itself, bring it home and do whatever he wants with it. Or he can just reset passwords or whatever. Now, let's go back to pass the hash a little bit. I have heard a lot of times that salespeople were trying all the poor enterprise guys to convince that, oh, don't worry about pass the hash attacks, just buy our smart card or just buy our one-time password tokens and you will be safe. Unfortunately, this is not how Windows networks and Windows NTLM works, because at the end of the day, these smart cards and one-time passwords, they just generate a static NTLM hash in the Windows domain controller. And although there is no password, basically, which matches this NTLM hash, but whenever the attacker can steal this NTLM hash from the user's machine or from whatever, then attacker can use the same hash to authenticate to all the resources without needing any smart cards or one-time passwords. There is an awesome tool which is now in the proof of concept state, but this is a very great tool for attackers, which basically automates all the hacks I mentioned to you, and this tool is called DevStar. I'm sure you cannot read it, but this is not important at the moment. What really happens when you as a red teamer or penetration tester starts DevStar in an environment, that it will query the, first you need access to a machine with user privileges, and this is where DevStar starts, and it will query the domain for all the info it needs, which was used in Bloodhound as well, like who can administer what, who is logged in where, and which users are in which groups. And whenever it finds these informations, it starts to exploit all the machines. It has some built-in exploits, how it can start exploiting machines, or if the tool already gathered any hashes from the memory, it will use the hashes to move laterally between the computers. And after like 3 seconds in a lab network, it can gain automatically domain admin privileges from a user privilege, which is pretty cool. So what does it mean for any penetration tester? Will they be out of job? Actually, I don't think so, because the good thing about automation is that it will find all the low-hanging fruits, and now the penetration testers can focus on more complex ways to attack the system itself, or be more creative or stuff like that. Okay, but let's just finish the offensive part here, because I think we always knew that everything can be hacked, but I think most of you are on the defensive side here. So what can you do to defend your Windows networks? First of all, I highly recommend that you use unique local admin passwords on every machine, which is good because now the attackers cannot use hashes to move laterally between the different computers. Previously, what I recommended that you should use a fixed password, and you append, for example, the machine name to this password itself, and you use this on every computer. And now the hashes are unique and the passwords are unique on every computer, but still you can easily manage it, and you only have to know the base password and the machine name to authenticate to it. So it was easily scriptable, and it was not breaking operations. Luckily, Microsoft realized that this is a problem they have to solve, so they have created this tool called Microsoft Local Administrator Password Solution, which I have not tried it so far, but I have heard good things about this. Have you used this tool? Hands up. No, no one. Please try this. I hope that it's a good solution. Of course, you should separate all your domain admin workstations from all the others, and this means both from a network side or physically, because it's not a day-to-day use case that any user should access domain admin workstations through SMB protocols or something like that. If this is how your network works, then you have huge problems. Also, domain administrators should log in as domain administrators on servers only. Usually there is no need that they use their workstations to be logged in as domain administrators. And last but not least, don't use the same workstation for emailing or web browsing and for domain administrator tasks. Just please don't do that. As mentioned, you should set SMB signing to prevent all the relay attacks. There is this Microsoft tool called Microsoft ATA, and if you check this link, you can find a very good paper from Microsoft itself, which basically lists all the attacks I have mentioned in my presentation and how AutoTool will detect all these kind of attacks. But it turns out that this solution is not perfect as well, because it can only detect those kind of attacks where the domain controller is involved in this attack scenario. And there is a guy who played with this Microsoft AT tool, and he found an awful lot of bypasses, how he was able to gain domain admin privileges, but without triggering any alert on the Microsoft AT tool. But still, for finding all the basic hacks, it's a very good tool. And that's all I wanted to share with you. Thank you for your attention. Questions here. Comment: copying files to folders where service executables are found is linked to admin privileges, isn't it? For example, like program files, Windows folder, etc. Yes, by default, this is how it should work. But in enterprise environments, we see a lot of in-house made services, and the way developer works, that something is not working, so they are giving more and more privileges to the service itself, and at the end of the day it will work, but they forgot to remove all the privileges from the service itself. So this is how we can find services which are hackable this way. Questions: can you talk about, explain the golden ticket domain attack? I could, but it will take me like 20 minutes to do that, so I really don't think I have the time for this now. But you should Google Balazs Bucsai, who had a presentation about golden tickets like 4 years ago, and it's a very good presentation. I recommend you to do that. Is Bloodhound open source? Yes, it is open source. How complex does the Windows domain security audit get for large enterprises with dozens of domain controllers and domain admins and even more local admins? I'm not sure I understand the question, but I will not answer this question, but something else. I know that the guys tried to use this tool in an environment with like 300,000 computers, and it took Bloodhound like 1 whole day to query the domain controllers and build up all the graphs, and turned out that it still worked. So Bloodhound even works in very, very complex environments. And that's all the questions. Thank you.